class. Today's topic is all about fluids and hydration. It's a good one because everyone can relate to the benefits of good hydration, and I think everybody's got a story about what it's felt like to be dehydrated. And normally, to start the class off, what I do is I have students pair up and ask each other about their hydration practices. Have they ever experienced dehydration? What were they doing? How did it feel? And what did you do to recover? And since we can't do that today, I am going to ask you at least to keep those questions in mind as we're going through everything to do with what it's like to be hydrated and our hydration practices and all of that, and make some connections. So on our first slide, what we're going to talk about really are just some basic definitions, because you know that's pretty much how I always start the class off, so that we have a good understanding of what we're going to be talking about. So hydration is basically the process of consuming enough fluids in an adequate amount to support body tissues. And then we talk about a couple other different states of fluid balance or fluid imbalance, and we want to talk about dehydration. So dehydration is actually the process of becoming underhydrated. And then there's a term, maybe you've never heard of it before. It's actually called hypohydration, hypo meaning low or under. So hypohydration means underhydration. And this is basically defined as a state of being water deficient due to losses of body water and inadequate consumption. So a lot of times the terms dehydration and hypohydration are used interchangeably, but technically there is a difference. Dehydration is actually the process of becoming dehydrated, and hypo or underhydration is actually the end result. I'll never quiz you on that, but I do like to let you know that there actually is a subtle difference between the two. All right, so everyone has been practicing good hydration this semester, because I know I started off on the very first day encouraging you all to start drinking more water and more fluid in general and less sugary drinks. And so if I were to ask you, would you like better endurance? Would you like better mental focus? Less fatigue, decreased risk for injury, better recovery? Almost everybody would raise their hand and say, yes, I do. I definitely would want that. Well, water and fluid intake on a schedule and maintaining good hydration, there's a lot of good research to support that it will do all those things for you. Okay, so I have this little meme here on the PowerPoint saying, I'm not dependent on my water bottle. I just need it by my side everywhere at all times. A little bit of a joke, making fun of it, but it is really important. If you actually carry water with you, you will tend to be better hydrated because it reminds you to drink. And one last key thing on this slide, optimal hydration is not only a balance or it's not only related to fluid intake, water intake, but also electrolytes as well. All right, so how do athletes lose body water during exercise, and what are some warning signs of the process of dehydration? So basically, athletes lose body water during exercise in two ways: sweat and exhaled vapor. So I always use the example, if you go up to a window or a mirror and you go, and you breathe on it, you'll see condensation there, and that's showing you that there's loss of moisture. So those are the two roots of body water loss, all right? And then some signs or warnings, symptoms of dehydration: fatigue, weakness, thirst is a big one, nausea, lightheadedness. EAMC stands for exercise-associated muscle cramps. There's a category of that called heat cramps, and we're going to talk about why they may be or may not be associated with dehydration later on. Anyway, poor concentration is another one, and then just general overall decreased performance. Okay, so when we think about how dehydration affects your performance, we definitely know that athletes lose a competitive edge. And we have a general guideline, and this is something that we're going to spend some time on now. Losing greater than 2% of your body weight has been scientifically shown to definitely decrease your ability to perform. So we encourage athletes to actually drink to match what's called their sweat rate, how much sweat you lose during the period of time that you're exercising. Now we know that some degree of dehydration will occur, but the goal is to minimize it to 2% of your body weight. Now, interestingly, sweat rates can vary from athlete to athlete. Depends on exercise intensity, how long you're going, whether or not you're acclimatized, the heat, the humidity, the altitude. All of those play a role in affecting how much you sweat. And an athlete's sweat rate can vary from 0.3 to 2.4 liters per hour. So, think about a liter in a quart being almost equivalent. So that'd be almost 2.5 quarts in an hour. So that's quite a lot of sweat. So we're going to go through a little calculation here. I want you to use your own body weight so you can figure out what 2% of that is. So you would know that you shouldn't lose any more than that during your workout. So let's just use the example of a 150-pound athlete. Okay, multiply that weight by 0.02, which is representative of 2%. So you take 0.02 times that 150 pounds. That means this athlete should not lose more than 3 pounds during a training session or a competition. So hopefully you guys will do that with your own body weight so you can apply this information to you. All right. So I mentioned sweat rate. So you might be wondering, what is that? All right. Well, we can actually estimate how much sweat an athlete loses when they are training, practicing, competing. And we do that by taking body weights and keeping track of how much fluid that they drink. So our formula, okay, is sweat rate equals your body weight before activity minus your body weight after activity plus how much fluid you consume during the activity. So this means you actually have to keep track of how much fluid you drink. So that's pretty easily done. If you have a water bottle and you know how many ounces is in it and you know how many times you fill that water bottle, and drain it during the time that you're practicing or competing, that will give you the amount of fluid that you're consuming. So we're going to look at an example here. Francisco weighed 170 pounds before his soccer practice, and he weighed 160 pounds after his soccer practice. Right? During practice, he consumed 20 ounces of a sports drink. His practice was 2 hours long. Is Francisco meeting his hydration needs? So something to keep in mind, a pound is equal to 16 ounces. All right, so we're going to be using that in just a minute. All right, so sweat rate, weight before activity, 170. Weight after activity, 168. Right, and then we're going to add in the 20 ounces of fluid that Francisco consumed. So if we do the math, we get 2 pounds plus 20 ounces. All right. And since there's 16 ounces in a pound, that's another pound and a quarter. So 2 pounds plus 20 ounces equals roughly 3.25 pounds of sweat lost during that 2-hour practice. So that's the sweat rate. Okay. Now we're going to see if Francisco's doing a decent job of hydrating. So remember the goal we saw on the first slide there, or the slide previously. The goal or the recommendation is to limit body weight lost from fluid to 2% of your weight. So Francisco weighs 170 pounds. We're going to multiply that by 0.02, seeing that Francisco should not lose more than 3.4 pounds during his exercise session. Okay. So how did Francisco do? All right. So the recommendation is to limit his sweat loss to 3.4 pounds. Right. The sweat rate was 3.25. So we can see that Francisco did not exceed that limit of 3.4 pounds. So he's meeting the recommendation, okay, of not to lose more than 2% of his body weight through sweat. However, I think Francisco could do a much better job of hydrating, in that the absolute goal for athletes is to try and drink as much as they sweat. And if we're looking here, we can see that Francisco's not quite doing that. He's falling short. So he would definitely benefit from drinking more than 20 ounces during his practice. Okay. So technically, yes, he falls within the recommendation. But if I were working with him, I'd be like, yes, you meet that recommendation, but you could be doing a better job of things. All right. And we'd encourage him to drink more. Right, so that ends this part of the chapter. We're going to close out the video now, and when we come back, we're going to talk about heat-related illnesses.